Hello everyone, this is Pratul Prakash with my team Hector Medina and Victoria Anderson from Machine Learning class of University of Cincinnati. In this presentation, we have tried using machine learning to explore hospital data under the guidance of Professor Chang Li. In this presentation, we have explored the potential of machine learning in predicting specific outcome in COPD patients. The goal is to apply at least two machine learning techniques to identify the best option for accuracy prediction of readmission, heart disease, hypertension, and readmission within 13 days. Within 30 days. We have used KNN and logistic regression method to achieve this goal, and towards the end we will discuss the similarities and difference between using these two models. Before we start, we would like to thank Department of Biomedical Informatics at University of Cincinnati, who provided us de-identified data from 2012 till April 2016. This data was a result of a primary diagnostic of a patient who are 18 years or older. The data was focused on readmission rate for medical condition, which is one of the major burden on healthcare expenditure in our country. In this presentation, we will be exploring 5 questions. What model could do well when predicting or simulating about number 1, a PCP would predict whether a readmission will occur. 2, hypertension would predict whether a patient has heart disease. 3, obesity would predict whether a patient has hypertension. 4 and 5th combined, certain risk factor would predict whether a patient is readmitted. And the 5th one is specifically focused on if readmitted within 30 days. Next, let's look into the methods and data analysis we applied in this presentation. First, starting with the characteristics of data. Our data has about roughly around 11,000 observations and 57 features. We used Pandas data frame to analyze the initial data. As you may see, we have used again Pandas describe and t-type feature to understand the data dictionary of our data. The data has features like age, admission date, PCP, last admitted date, and so on. And in next slide we will see how we have correlation between the data. For the initial analysis, we started with some basic chart to get the mean, median, mode, and so on from the data. For an example, mean length of stay was 1.7 and the mean age was 52. Average cost was about 35,000 with a standard deviation of 95,000. The standard deviation for the length of stay was 7 and age was about 16. After initial review of our data, next we started to cleanse our data and at the same time to understand our data better. So we utilized again Pandas data frame is null, and how many null are in our data frame. So we applied df.isNull or df.isNullSum. These are the two features that gave us to minimize or reduce the number of features and eliminate the redundant data. After performing the cleansing, we started visualizing the data. Majority of the patients were in in the age group of 40 to 60. Age was fairly normally distributed. And the second graph shows where there was more variance in age among the males compared to female. Next, we slice the data by grouping them to understand it, like how old the patient were by admission type, how old the patient were by readmission within 30 days, or the gender, and this gave us more understanding of data. So let's start with the next evaluation model. We have evaluated the model using both unsupervised and supervised learning. So let's discuss the unsupervised learning with a categorical variable first. In this approach, we split the data into training dataset and test dataset. We decided the ratio to be 60 to 40. And then we created models using both KNN and logistic regression. Then we compared the model accuracy and decide what is the best model. So in upcoming slide we will look into these features. So here's our finding of unsupervised learning. This model is to find the question answer for the question 1 we discussed early. To know having a PCP would predict whether readmission will occur. KNN model scored 0.34 versus logistic regression scored 0.67. The score indicates that logistic regression model predicts this more accurately than KNN model. In this model, we try to find the answer for question 2, where having hypertension would predict whether a patient has heart disease. KNN scored 0.67 and so the logistic regression. So in this we can use either model to tell having hypertension if you have or if the patient has a heart disease. In this model we try to find the answer for question 3, whether being obese would predict whether a patient has hypertension. KNN scored 0.09 and so does the logistic regression. Both prediction were the same, meaning they both can be used to predict whether the obesity status of a patient indicates that they have hypertension. The next model we try to find the answer for having a risk factor would predict whether a patient is readmitted. KNN scored 0.58 versus logistic regression scored 0.67. The best score was high logistic regression, meaning it was a better model to predict whether having a high risk factor would lead a patient to be readmitted. In the fifth model, we try to find the answer whether having a risk factor would predict whether a patient could be readmitted within 30 days. KNN scored 0.39 versus logistic regression scored 0.41. In this scenario, both scores were relatively low and not good model for predicting readmission within 30 days with the given risk factors. Next, we had the supervised learning evaluation module for the continuous variable. We tested whether there were correlation in the data, and we found that most of our data was categorical in nature. Seaborne correlation matrix and heat map depicted to identify the correlation. So let's, in conclusion, KNN or K nearest neighborhood and logistic regression were both suitable machine learning methods for this data and generated good models that were comparable in most cases. There were some differences in accuracy and in most cases, one model was better model than the other. Continuous variable show no strong relationship across any of the variables, and prediction could not be made using that data set. With this, we would like to acknowledge Department of Biomedical Informatics of University of Cincinnati, especially Dr. Umesh Singh, who shared the data with our team, and Dr. Lee for the new knowledge we gained from this class. We thank you all for watching this video. Please leave your comment and suggestion. Thank you again.